Good evening, and welcome to Strang Theory. Today, we're going to be looking at a North American Midwestern science teacher in his natural habitat. Let's watch as he prepares a demonstration for his classroom. Today's demonstration will use water to show the power of hydrogen bonds. Oh, looks like you dropped a couple, Mr. Strang, but that's alright. There's plenty of water to replenish the supply. Now watch as he drops not one, not two, but several drops of water on top of this penny. And notice how the water not only spreads over the penny, but actually begins to aggregate on top of the penny itself. In fact, the water becomes so thick that it actually has a greater depth than the penny. What causes this phenomenon? Hydrogen bombs.
No, bonds. Bonds? Like what keep atoms together? Who vetted this guy? You know, I don't even think he's Australian. Hi, I'm Mr. Strang, and I have a question for you. Are you, alive? Assuming you are, that means that most of your body is composed of water. Depending on your age and fitness, anywhere between 50 and 70% of your body is composed of water molecules. Water helps transport materials throughout your body, regulates your metabolism, and even helps break down other substances so your body can use them. And it's not just humans. All plants, animals, fungi, and bacteria, virtually all living things depend on water to live. But why water? What makes this specific molecule so important to life? Well, today we're going to talk about the properties of water, specifically how it helps living things function. We're going to talk about 4 specific functions: cohesion, adhesion, capillary action, and surface tension. Let's take a look at our documentary footage again to see these properties in action. Notice as the water is being dropped on the penny, it sticks to itself. This property is called cohesion. As the water begins to rise, it seems as though it should fall off, but yet it's sticking to the penny instead of overflowing. This property is called adhesion. Cohesion is defined as a substance's ability to adhere to itself, whereas adhesion is a substance's ability to adhere to another substance. The water sticks to itself through cohesion, and the water sticks to the penny through adhesion. Next, let's talk about capillary action. Now, you may not realize it, but you've actually engaged in capillary action yourself. Let's say you're at a restaurant, but you're bored, but you got your water and your straw, so you do one of these. That is capillary action. Wait, what? Capillary action occurs when water uses its adhesive and cohesive properties to stay in narrow spaces, often in opposition to gravity. The gravity is still pulling on the water inside the straw, but it's not a strong enough force to overcome the adhesion and cohesion of the water. When I let go, however, air can then freely flow through the top of the straw, and that additional pressure can push the water out. This is really important because capillary action allows water to transport itself through your capillaries and through the vessels of plants. Interestingly enough, this actually doesn't work for all straws. Watch what happens when I use a really big straw. Why did that happen? Well, when you use a larger straw, there's actually a greater volume of water. So when that occurs, there's more water for gravity to act upon. When there's more water for gravity to act upon, that means the force of gravity can actually overcome the adhesive and cohesive properties of the water. So instead of the water staying in the straw, it just flows out. Finally, let's talk about surface tension. Surface tension is defined as the tension maintained at the surface level of a liquid that's attracted to itself. Pretend you're going off a diving board and for whatever reason you really want to hurt yourself. How are you going to dive in the water? Well, you could go in head first or feet first or try a cannonball, but if you really want to leave some red marks on yourself, You have to do a belly flop. The reason belly flops hurt so much is because you're spreading your entire mass over as large a surface area as possible. In turn, more water and therefore more cohesive and adhesive forces work together to push back against your body. This phenomenon of the water pushing back against your mass is surface tension. Surface tension can be useful in biology because the water can act as a sort of barrier to substances that otherwise wouldn't have any. So that's water and some of the properties that make it useful. But we know we don't just have water in a vacuum, so to speak. It always mixes with other things. How and why does it do that? Well, that's what we're going to talk about next time with solutions. But first, let's go over what we learned today. We talked about water and how the hydrogen bonds between water molecules give water some very specific and important properties. We discussed cohesion, adhesion, capillary action, and surface tension. We learned that cohesion is a substance's ability to adhere to itself, like water droplets running towards each other, and that adhesion is a substance's ability to stick to something else, like the water droplets staying on the penny. We use straws to demonstrate capillary action, or the phenomenon that occurs when adhesive and cohesive properties work together to stay on the inside of a narrow surface. And finally, we talked about surface tension, the property of water that allows us to experience the joy of a belly flop. Thank you again so much for watching. If you found this video useful or informative in any way, please feel free to like and subscribe, and if you have any ideas or questions, leave a comment below. Thanks again, and I hope to see you next time. Remember, have fun, study hard, learn well. So who booked that guy anyway? Oh, Brad? Of course it was Brad. Come on, Brad.